This is a point on a 2D plane with coordinates x1 and y1. And this is another point on the same 2D plane with coordinates x2 and y2. These 2 points live on the same line. And in this video, we are going to find the equation of this line. The first thing we need to find is the slope of this line, which is denoted by m. We can find the slope of this line by dividing the y-coordinates by the x-coordinates. It doesn't matter whether we use y1 minus y2 divided by x1 minus x2 or y2 minus y1 divided by x2 minus x1. And this is the slope of this line. To put it in other words, suppose that you are running in the positive direction of the x-axis. The amount of rise or sometimes fall to reach the next point can show us the slope of this line. Now take this point with its coordinates as 2 variables x and y. They can change. We can use one of the points, here I used x2 and y2, and this variable to find the slope, and this gives us the equation for this line. Pay attention that m can be calculated as we did before. And as you can see, we can write the equation of this line using a slope and a point or 2 points and write the equation as you can see. Now take a look at this line. This line has a positive slope and m is positive. The next picture you can see has a negative slope and m is negative. In this diagram, you can see a line with 0 slope, so m is 0. And finally, for this line, which is parallel to the y-axis, we cannot actually define a slope. For the positive slope, the run is positive and the rise is also positive, so the slope is positive. For negative slopes, if we take run to be positive, the rise will be negative or somehow we have a kind of fall. For the case of 0 slope, it doesn't matter how much you run, you don't see a rise or fall. And finally, for the last diagram, all the points on the line have the same x-coordinate and so you cannot run. Now, take these 3 points, -2, 4, 1, and -2, 3, and let's find the equations for these 3 lines. First, we are going to use this formula to find the slopes. The slope of the blue line is 1 minus -2 and 4 minus -2, which is 1/2. The slope of the green one is 1 minus 3 over 4 minus -2, which is -1 over 3, and it is negative. And finally, the slope of the white line is undefined. So now that we have the slopes, m's, we are going to use this formula to write the equations. For the blue line, I first used m and the point 4 and 1 to calculate the equation. And as you can see, if I use -2 and -2 and the same m, I will get the same equation. For the green line, we can do the same thing with one of the points, and we get y is equal to -1 over 3x plus 7 over 3. And for the white line, you can see that for all the y's, we have the same x, so we can write it as x is equal to -2. Now pay attention to these 2 points, that the lines, the blue line and the green line, intercept with the y-axis. And if you pay attention to the equations of these 2 lines, the blue line and the green line, you can see these the same numbers. So if we have the slope m and the y-intercept of a line, we can actually write its equation. Now let's graph different scenarios for this kind of line. For example, for this example, m is negative, and as you can see, the y-intercept is positive. When m is 0, we can write the equation as y equals a constant, which is the y-intercept. And sometimes we have a line that doesn't have any interceptions with the y-axis, so we can write it as x is equal to a constant. In this diagram, as you can see, m is positive, but the y-intercept is negative. And in this one, m is negative, the slope is negative, and also the y-intercept is negative. We can write the equation of a line in its general form in the form of ax plus by plus c equals 0. I can take ax and c to the other side and divide by b to have this form of equation. If you compare it to what we actually talked about in the previous slide, we can see that m, the slope is minus a over b, and the intercept is minus c over b. So let's see what happens if a, b, or c is 0. If a is 0, we have a line with 0 slope. If b and c are both positive, we have a line which is lower than the x-axis, and if b and c have different signs, we will have a line which is over the x-axis. In this case, the slope is 0 and the intercept is minus c over b. For the case that c is 0, we can write the equation as minus a over b multiplied by x. Here the slope is minus a over b and the y-intercept is 0. It means that the line intercepts with the origin of our 2D plane. And finally, if b is 0, we can write the equation of the line as x is equal to minus c over a. In this case, m is undefined, and as this line is parallel to the y-axis, it doesn't have any intersection with the y-axis. Now take this line as an example and we are going to find the slope and the y-intercept. We first take the x term and the constant term to the other side and we can write the equation like this. So we can say that the slope is minus 2 over 3, which is a negative slope, and b is 7 over 3, which says that we have a y-intercept at this point. If we want to graph this line, we can use this chart. If x is 0, you can easily see that y is 7 over 3. What if y is 0? If we put y to 0, we can see that x is 7 over 2. So we write it here, and now let's graph it. This is the y-intercept, and this is the x-intercept of this line. And the line that matches these 2 points together is the line we're talking about. Now let's take these 2 points and find the slope again, and we will see that it's still minus 2 over 3. We can actually write the equation of a line when we have 2 points, when we have a slope and a point, and when we have a slope and the intercept. And you know that intercept is another point. So if we have these 2 points, x1 and y1, x2 and y2, we can use this formula to write the equation of the line. If we have the slope m and another point x1 and y1, we can write the equation like this. And finally, if we have the intercept and the slope of the line, we can write it using this equation.